Hello, Algebra 1 students. Welcome back. What we're going to do today is talk about exponential growth and decay. We're going to be combining sections 8.5 and 8.6, and we are going to be doing them in two segments. So there's two videos that go along with 8.5 and 8.6. In the first video, we're going to be primarily talking about graphing and writing rules. And then the second video, we're going to be focusing on the applications of exponential growth and decay models. Okay, so let's jump right in here. What I want us to talk about first is just the general form of an exponential function. So that's going to look like y equals ab raised to the x power. Okay, now each number in this function is going to tell us a lot of important stuff about our graph. So A is going to be what we call our starting point. Okay, and that also just so happens to be the y-intercept of the graph. So A is where the graph will cross the y-axis. So A equals the y-intercept. Okay, now B is what we call the constant multiplier. All right, so let's jump right in here and let's look at this first example. So what we're going to do is we're going to make a table for the graph, okay? So what I want you to do is I want you to take your first point there, -2, and we're going to plug it into the function. So 2 to the -2 power, and we want to rewrite that with no negative exponents. So we're going to flip that guy around and say 1 over 2 squared, which happens to be 1 over 4. Okay? Now let's plug in -1. So when we plug that in, we get 2 to the -1. Okay? Write it with positive exponents, so 1 over 2 to the first, which is 1/2. Okay? Plugging in 0, we all should know 2 to the 0 power, that's 1. 2 to the first is going to be 2, and then 2 squared is going to be 4. Okay, so let's put this stuff on the graph. So let's see here. We have -2, 1/4. We have -1, 1/2. We have 0, 1, 1, 2, and 2, 4. Okay, so as you can see, the graph is going to come from the left. It's going to travel along the x-axis, and then it's going to start curving up, and it's going to shoot off to the sky. Okay, so let's talk about domain and range. So the domain of the graph is the x. What sorts of x values can I plug into this function? Or if I'm looking at a graph, how does the graph span the x-axis? So if you look at the graph, it's going to continue going up and right forever, and it's also going to continue to go left forever. Okay, so what that means is I can plug in any value for the function for x, so x is all real numbers. Okay. Now for the y value, so the range is the y value, okay? If you notice, the graph is up above the x-axis. And in fact, it's never going to touch the x-axis. It will simply always stay above this x-axis. So what that means is we are going to only see positive y outputs. So the way we're going to write the range is we're going to say y is greater than 0. Okay, let's go ahead and jump into this next graph. Again, we're going to start off with a table. So what we're going to do is we're going to start by plugging in the point -2. So 1/2 to the -2 power. Okay, so we're going to rewrite by distributing our exponents, and then we are going to simplify. So we're going to We don't want any negative exponents, so we're going to flip those guys around. Okay? So 2 squared over 1 squared, and that's going to give us 4. Let's plug in negative 1. So 1/2 to the negative 1 power, distributing your exponent, 1 to the negative 1 over 2 to the negative 1. Okay, flip it around. So 2 to the first over 1 to the first, and that gives us an output of 2. 1/2 to the 0, everyone should know what that is. That's 1. And plugging in 1/2 to the first is just 1/2. And then 1/2 squared, we distribute our exponents. So 1 squared over 2 squared is 1/4. Okay? So let's go ahead and graph this. So let's see, -2, 4, -1, 2. We have 0, 1. We have 1, 1/2. And we have 2, 1/4. Okay? So this time the graph is going to be coming from the sky, and it's going to decrease, and then it's going to follow along this x-axis forever. Okay? So this one is going to have actually the same domain and range as our first example. Okay? So the domain is our x, so the graph is going to go left and right forever. So x is all real numbers, okay? And the range, again, since we're above this x-axis, okay, our y outputs are always going to be positive. So what we're going to say for the range is that y is greater than 0, okay? So now, as a rule of thumb, what we can say is as x increases, y increases. So the graph, for example, number 1 represents exponential growth. Okay? So the graph is going up. As x increases, the y's get bigger as well. And that is always the case if a is a number that is greater than 1 and if b is a number greater than 1. Okay? Now, if we look at example number 2, the graph is decreasing. It's going down as x gets bigger. So that we say is exponential decay. Exponential decay. Okay? If the y values are getting smaller as the x values increase. And that is going to be the case if a is greater than 1, but b is a number that's greater than 1, or excuse me, greater than 0, but less than 1. Okay? So we can see that because we have the function y equals essentially 1 times 1/2 to the x power. And this number, 1/2, is a number that's in between 0 and 1, versus example number 1, where we have y equals 1 times 2 to the x power, and this number is a number greater than 1. So 2 is greater than 1, that represents growth, and then 1/2 is a number that's less than 1, that represents decay. So I'm getting smaller, okay? And that also means our common multiplier, it means that I'm multiplying by 1/2 each time, or I'm dividing by 2. Dividing by 2 means I'm getting smaller for every input that gets larger. So let's look at example 3, and we're going to talk about what happens if a is negative, okay? So we're going to make a table, and let's start by plugging in the point -2. So what this is going to look like is -1 times 2 to the -2. Now, what this is going to give us is -1 times 1 over 2 squared. Now, you can't really see that. Let me rewrite that. 1 over 2 squared. Okay, so 1 over 2 squared is 1/4, so -1 times 1/4 is -1/4. Okay, Let's plug in -1. So we get -1 times 2 to the -1. So that's going to be -1 times 1 over 2 to the first power, which is 1/2. So -1 times 1/2 is -1/2. Okay? Let's plug in 0. -1 times 2 to the 0, that's -1 times 1, so that equals -1. And 1, we get -1 times 2 to the first, which is -2. And -1 times 2 squared is -4. So let's go ahead and plot these on our graph here. So what we have is we have our first point at -2 1/4, and then -1 1/2, 0 -1, 1 -2, and 2 -4. Okay? So the graph is going to come along this x-axis and it's going to dip down and then it's going to go down to the ground forever. Okay? So the domain and range are going to be a little bit different. Remember that the domain is our x, so the graph still is going to continue to go right and left forever. So the domain is going to be all real numbers. Okay? But for the y, the range is going to change a bit. Okay? So if we notice that instead of being above the x-axis, this time we are below the x-axis. Okay? So our y outputs are only going to be negative numbers. And in fact, that graph is never even going to touch that x-axis. It's going to get infinitely close to it, but it will never actually touch the x-axis. So what we will say for the range is we will say y is less than 0 because we are below the x-axis. Okay? Now comparing this to our first function, if we look at that first function, y equals 1 times 2 to the x power, that graph looked like this in example 1, but now our graph of y is equal to -1 times 2 to the x looks like this. Okay? So what's happening is the graph is being reflected over the x-axis. So it's a reflection over the x-axis. Okay? All right, let's go ahead and flip over to the back side there, and we're going to talk about how to write a rule for an exponential function. So I'm going to give you 3 steps for writing a rule here. Okay? So the first thing is if you have a table or a graph, you are going to find the y-intercept. Okay? So y-intercept, and that's going to be a. Okay, so the y-intercept is a, and we can identify the y-intercept when x is equal to 0. Okay, the next thing is that we are going to find our common multiplier. So we're going to find our multiplier, and that will be the value of b. Okay. And then our third step is to just plug those guys into our function. I'm going to slip a y in right there. Plug it into our function. Y is equal to a times b to the x power. Okay? So let's go ahead and let's try example number 4. And we're going to use that 3-step process. So step number 1, what we want to do is we want to find where our y-intercept is, and we look for that when x is equal to 0. So I find this value here in the table where x is 0, and that means that y equals 8. So that is the value of a. So a equals 8 because x is 0, and that's our y-intercept. The second step, step number 2, is to find the multiplier. Okay, so you look at your y values and you say, okay, what do I multiply 2 by to get 4? Well, that's 2. And 4 times 2 makes 8. And 8 times 2 makes 16. Okay, so our common multiplier, b, is equal to 2. And our third step is to plug in a and b into our exponential function y equals a b to the x power. So then our model will be y is equal to 8 times 2 to the x power. Okay, so that will be the answer right there. That is our rule for the function. Let's try number 5. Okay, so we are going to follow that 3-step process. So step number 1, we're going to find where x is 0. Okay, so when x equals 0, y equals 27. And that is the value of a. So a equals 27. Next, what we're going to do is we're going to find our common multiplier. Okay, so 3 times what gives us 9? Well, 3 times 3 gives us 9. And 9 times 3 gives us 27. And 27 times 3 gives us 81. So our common multiplier, b, is equal to 3. So the third step is to take our exponential rule and plug in a and b. So our rule then is y equals 27 times 3 raised to the x power. Okay, so that is our rule right there. All right, let's look at example 6 here. Okay, this one, let's see if you notice, this guy is decreasing. As we increase in x, we are decreasing in y. So this one is going to be an exponential decay function, whereas if you notice, say on example 4, where we are increasing, our y values are getting bigger. Okay? All right, so let's do this. First, we're going to find where x is equal to 0. So when x equals 0, y equals 1, and that means that is the value of a. A is 1. Our second step, we're going to find the common multiplier. So since we are decreasing, this represents exponential decay, we have to think about what are we multiplying by to make a function get smaller. So some of you may know that 4 divided by 2 is 2, but what number could I multiply 4 by to get 2? And that would be the same as 1/2. So if I multiply by 1/2, that's the same thing as divide by 2. 2 times 1/2 is 1. 1 times 1/2 is 1/2. Okay? So b is equal to 1/2. And lastly here, third step, we want to plug a and b into our function. So then our rule is going to be y is equal to 1 times 1/2 to the x power. Okay? Now essentially we could just write y equals 1/2 to the x power, because when you multiply by 1, nothing really happens. Okay? All right, so let's look at lastly here example 7. Okay, we'll follow again that 3-step process. So number 1, we find where x is 0. So x equals 0 and y is equal to 1. And that means that a equals 1. Next, we are going to find our common multiplier. Okay? So if you look at the function, 5 divided by 5 makes 1, or we can say 5 times 1/5 makes 1. 1 times 1/5 makes 1/5. 1/5 times 1/5 makes 1/25. So our common multiplier b is 1/5. Okay? And lastly here, we are going to plug those into our function y equals ab to the x, and that's going to give our rule of y equals 1 times 1/5 raised to the x power. And just like the last example, we don't really need the 1 there, so we can simplify here and say y equals 1/5 raised to the x power. Okay? All right, so next, these last two examples here, what we're going to do is we're going to do the same process, but we're going to do this by looking at the graph only, okay? So let's take a look at this graph, and if we look at step number 1, that is where we look to see where the graph crosses the y-axis, okay? Where is x 0? So x is 0 when y equals 8. So that means that a is equal to 8, okay? A is 8. All right, so next we need to find our common multiplier. And we're going to be doing that by looking at the y values. I have a y value of 8, and now it got smaller, and it went from 8 to 4. So how does an 8 turn into a 4? Well, we would have to divide by 2. And that's the same as saying times 8 by 1/2. Times it by 1/2. Okay? So b, our common multiplier, is 1/2. And the third step is to plug in these values in for a and b. So what we get is y equals 8 times 1/2 raised to the x power. And that is our rule. Okay? So last example here, we're going to go through those 3 steps one more time. So we have step number 1, which is to find the y-intercept on the graph. Where does the graph cross the y-axis? At 10. So when x is 0, y equals 10, and that means that a is equal to 10. Okay? Step number 2 is to find the common multiplier. Now on this graph, what happens is we went from 10 to 12. And this one might be a little more tricky to solve in our head. We have to think about what number did we multiply 10 by to get 12. So what we can do is we can set up a little equation to help us to think about what number can we multiply 10 by to get 12. So we can say 10 times, say, x equals 12. So 10 times what number equals 12? So if we just simply divide each side by 10, that means that x is equal to 12 over 10, and that is the number 6 over 5. So that is my common multiplier. Okay, this is our common multiplier. So that is b. So b equals 6 over 5. Okay? Now, the last step here is to then plug in a and b into your function of y equals ab to the x power. So we are going to plug that in, and we're going to say y equals 10 times 6 over 5 raised to the x power. And that is going to be our rule. Okay? Stay tuned for the next segment of 8.5 and 8.6 combined. That video will be 8.5 and 8.6b. And what you're going to do is you're going to get started on graphing your exponential growth and decay models. Remember, if you have questions, I hope you are visiting the math tutorial lab in F107 so you can get those questions answered. And I hope you have a lovely rest of your day, and we will see you for the next segment of exponential growth and decay.